All right, you're good.
Absolutely. So thank you so much for the time and the opportunity to present today. I will be speaking about our team Enscryb on we're a venture internally to Nokia. So I'm not representing Nokia in its purest form today. It's actually the Enscryb team. Again, about my background, I came from a power utility space. Previous to that, I was actually in telecommunications. So I have one of those operational telecoms backgrounds. Worked for an IOU in the Midwest, and then came to Nokia. Been there for about almost 8 years now. I do have global experience. I spent 3.5 years in Europe learning the European system and markets, etc., and currently pursuing my master's in energy policy. So we've got about 50 plus years experience in energy on our team, which helps lend some credibility there. So I'm going to go ahead and present the slides. I will tell you right now, I may not be able to answer all of your actual technical questions on the platform, so I know enough to be dangerous. My team is a team of Bell Labs researchers and PhDs and other experts in both the US and in Europe. And so when we talk, we do have some European examples because we're learning a lot around flexibility and renewable penetration there and bringing some of those lessons back. So bear with some of the comments and examples I use from the UK and other places. So let me go ahead and share my slides here. Okay. And while I'm in presentation mode, I may not be able to see hands being raised. I am quite informal, so please don't hesitate to interrupt and ask questions. I think it makes for a much more dynamic conversation. And since I can't see all of you, I don't know how receptive you are. If people are on their phones, I know I need to speed it up or change the tune a bit. But let's go ahead and talk a little bit more about this. Again, we are a Nokia startup venture. Our job is to take Bell Labs technology and commercialize it. We were looking at how do we use that technology. And again, and most of us know the cell phone era from Nokia, and there are 15 different Bell Labs patents in your phones, but nobody knows all this other work that goes on in Bell Labs. And so we took a software platform and a technology they developed and cross-pollinated that. Initially, it was being used for real-time video stream analysis. And since it's real time, there's not much else that's even more real time than electrons. And so we started looking at how does this apply to the power utility space and to energy in general. And we came across this idea of flexibility, which again is very, very prevalent in Europe right now and beginning to be spoken about here in the US. We really try to look at how we change looking at energy and how we balance. So rather than balancing from the top down, we're looking at balancing from the edge up. And while that's a provocative statement and controversial, perhaps with some of our transmission system operators and those who are GNT cooperatives, it is something that we need to think about doing differently as we see a lot of distributed assets coming online, behind the meter assets. How do we take advantage of those, and how can we ensure that the grid is properly modeled and can essentially incorporate and integrate those behind the meter assets and utilize whatever capacity is there rather than having to curtail it. And so we'll talk a little bit more about what that means. So again, the questions: how can we optimize that generation? How can we increase resiliency? I think that's a very big question right now in the US. I come from the Midwest, so we're used to having a lot of very dangerous storms and a lot of power outages. Can we increase our resiliency without having to expend a large amount of CapEx for that? And can we also look at offsetting extensive grid upgrades with a different solution? We call it non-wire solutions here in the States. I think that it's not necessarily that we don't need the upgrades, it's can we liberate some of that capital to utilize in places where we really know we have to upgrade, and maybe push down the line a little bit more of some of the other upgrades that we could get away with. I think the other questions that we still have that we don't have answers to is how do we keep up with the change in demand that we're seeing between data centers and AI, quantum, the Bitcoin mining that we see. And many of us as operators, we do our demand curves, and then it gets blown away by perhaps a fleet that's being electrified that we didn't count on, or maybe there's another one of our industry complexes that's going to go more renewables or have a large amount of renewables on tap that we didn't anticipate. And so I think there's a lot around being able to do scenario testing, and digital twins are really essential to being able to understand the what if scenarios that we see in today's grid. So is flexibility the answer to this? And this, again, when we talk about flexibility, I think sometimes it's a bit newer term. We talk about demand response a lot in the US. Flexibility is similar, but there are some nuances, I think, when we talk about flexibility. I think the industry globally is trying to harmonize on these terms. For me, at least, demand response is very much a black and white. It's either on or it's off. Whereas with flexibility, we look at harmonizing that a little bit and making subtle changes in the patterns to react to whatever's happening in the grid right now. And of course, we all know traditionally we just generate to meet the demand. And now we need to start looking at, can we massage that demand to meet what we have locally and then go up, a level to the next level of grid services. So let's talk a little bit about digital twin. This is the Digital Twin Consortium's definition, and I really like this definition. As I was preparing for this, I went and looked at McKinsey, I looked at IBM, I looked at NVIDIA, and they all had sort of similar definitions that were simplified, but didn't really capture the essence of what we do as a simulator product. And so I really think that these last two points here are really what we want to focus on here are these using real-time historical data to represent the past and the present and to simulate predicted futures. This is part of what we do here, especially around the simulation. So that's why our first product is called the simulator. But we also do this digital twin prototypes. This is when we're looking at these simulated futures with maybe assets that don't exist yet. So how can we create value or understanding around what the impact could be, and how we do that in a way that helps us make better decisions down the road based off of maybe some ambiguous information that may or may not be available. We don't always have perfect information right now, so we need to do some of these simulated predicted futures to understand what the options could be. So our platform is called, our company and our platform is called Enscryb. And what we try to do is through this digital toolbox, so to speak, we have two products one is done, and one we actually have released two of simulation, and we're getting ready to start the orchestration aspect. So what we really try to do is within the simulator product, we digest information. So that could be models of storage or generation that's out there, that's any forecasted or historical generation information. This could be demand curves that are aggregated. This could be any virtual assets that you're looking at putting out there. It could be, just pretty much anything of that type of behavior. We upload the resource data. We like to have as granular as possible. Usually in the US, we get 15-minute, maybe 5-minute intervals with the time series, but we can get up to 1-minute intervals. And again, eventually we'll do no real time. Once we have this resource data uploaded, we try to discover what happens with the optimality. How do we optimize based on certain objectives and based on the situation, including the constraints, et cetera. And so this is really the discover phase, is where we start running these what if scenarios, and we can change a few things here and there to say what works the best to meet my particular objective. And those objectives we see typically balancing is just a kind of a no. We know it has to balance, but we also look at economic values. We look at revenue. We can look at the additional revenue that could be gained from playing in different revenue opportunities, different markets, and stacking those markets. We can also look at what happens if I have, I add storage in a location. What size of storage does that need to be? If I want to do, X, Y, Z, if I want to be more sustainable, we're working on that objective now of where you can give weights to certain types of assets to make sure that you use those first and prioritize different things that way. We also look at the constraints in the system. So whatever transformation constraints you have or conductor constraints, we can also look at to see, especially with backup capacity in batteries, et cetera, I need to be able to keep a certain percentage of that for my own use. So if you've got an industrial customer that knows that we need to be able to utilize a certain amount of our backup capacity for our own operations, but we have another 35% that could go back to the grid during these specific times, we are able to take that into consideration and to model this. Once we have this configuration that meets your needs, that meets, whatever constraints are there, The next piece of this that we see as a natural evolution is we want to work to that optimization, that configuration. And so that's where we start deploying in this hybrid edge intelligent way. So we can have a centralized location on-prem with a hybrid edge at the far end, the far edge of that that system or that configuration. We can also put some different orchestration nodes in the middle, and we'll see a little bit of that in one of the diagrams I have. Once we do that, we can deploy that in a shadow mode. So we watch to see, is it behaving the way I thought it would in my simulator before we try to actually enact and enable that to activate the real-time steering. And then again, number 4 is automating that asset behavior in the real time and the directing. That's a scary place to be. We think about automatic dispatch, et cetera, et cetera. That's something I think that's a little bit down the road for many of our power utilities. And I understand, coming from one, I understand why that may be. But the fact remains is that as we have a lot more electrification, we have a lot more assets that are distributed, we need to be able to automate some of these things in near real time. And not just, again, at the transmission level, but we're looking also at the distribution level for that as well. This little diagram here just kind of shows you the value stacking that we do. A lot of this happens in Europe because if you look at example, the UK market, they have 24 different markets that people can participate in, both, you know, the distribution and transmission markets. And so their system operation is being pushed down. Not that the DSO is solely responsible, but now they do have responsibility in system operation hand in hand with the transmission system operator. And so they're really looking at a bifurcated system now where these very small amounts need to be balanced before it gets to the transmission level. And there's still challenges, and we'll talk a little bit about the end of the challenges that still remain with that. So again, our starting point, this DER flexibility. When we say distributed energy resource, we're talking about both generation, storage, but also demand. So there is flexibility inherent in the system. And our DER continuously announced that flexibility. And again, that could be any kind of explicit usage, statistics, or any kind of level governance that you have for that flexibility. Our orchestration node continually steers that flexibility reservation and activation. So we look at that amount that's there, we look at the envelopes. Again, this is the stuff that I can't talk to as well. However, I do know that while it's the flex activation is here, we have these boundaries and these constraints where we say you can't be beyond this. This is how much flexibility they have, and this is how much we're going to activate. And so we try to stay within these boundaries of that flexibility. And these may be very small adjustments that happen in, again, near real time, rather than being this on or off scenario, which we typically see now with demand response and curtailment. So again, we're optimizing for an objective, adhering to whatever constraints are on the system and over a typical horizon window, depending on what time frame we use. And we can use real-time stream processing, real-time protocols. We can use time of use processing, signals and price signals. We can look at power profiles as well as specific demand response commands. So this really integrates directly with any demand response program that you already have, but can also look at maybe doing more with that in the future around possibly flexibility markets, which is again what we're seeing across Europe. Is these flexibility markets now are specific for scheduling. They auction off and they activate the flexibility when it's necessary. Here's a few of the effects that we see from this when we start looking at the optimized utilization of flexibility. And that's really where our program sits from a digital twin perspective. We're not necessarily looking at the performance or the maintenance of an asset. We're not looking to steer the BESS system at the very low levels of looking at to see, you know, which cells are active and which ones are not, et cetera. What we're trying to do is bring it up a level and abstract some of that to look at a holistic view of aggregated assets. And these aggregation points can be in multiple layers, as we'll see in a moment. But we can actually prevent, with the right configuration, we can prevent congestion or alleviate constraints in certain areas. Again, we can look at market participation by aggregating flexibility to offer to the market, which I think is really where it comes into play within the G&T and the cooperative space. When you're looking at distribution and transmission, is being able to aggregate that flexibility and offer it up. Those types of things. Also, the cost optimization of consumption as we look at buying electricity from, you know, an IOU or another generator. Can we offset the cost of that by utilizing as much of the local generation first that we have, and then buy in a different way and operate a little bit differently that way as well economically. So again, when we look at this, one of the key focuses is these orchestration nodes or logical nodes for us. So this can run just in a cloud, depending on the size of your system and the need for resiliency at the edge. But we have this ability to do multiple layers of orchestration at different locations, depending on the assets that are electrically connected. So for example, if everything here at this level is actually on one feeder, you may not want to actually balance that at the feeder level. You could break that down into maybe one side that is residential and one side that is commercial, and operate those differently and have different objectives for those particular customers or those particular aggregation groups. And so we allow that flexibility, so to speak, no pun intended, in the system to allow the operators to decide maybe new services, maybe this industrial park, they pay a higher rate for a certain, level of availability, whereas maybe industrials, we don't have that. And so it allows you to offer new services to your customers as well, based on what you have available. We do mix supply side flexibility in the form of storage. We can also look at different models of thermal plus battery storage. So we can do a lot with the different resource types that we have. And the language that we use for our resource types is very flexible. So as new resource types and new technologies come about, we can actually model those quite simply within that by creating this new resource type. So as we look at some of these use cases, I think it's really interesting to think about these, because I think this is where a lot of people's minds go to, is how could we how could we use this? And some of the different things that we see with our customers and the people we speak to is demand planning is one of those, where we do our demand planning in a traditional way, but then something changes and we need to go back very quickly and redo that plan again. And being able to do different variants and compare those variants within our simulator is something that we're finding a lot of value in, because you can do different, you can do a very quickly do these different demand scenarios that may be a very low end plus what you would think would be the average, and then what happens if this particular data center gets built, and when that's coming online, how is that going to behave and impact things. The same thing with like EV fleet operators. That's something that we see a lot of. There's a lot of EV fleets going in, and charge point operator points are coming up everywhere. So how do we make sure that we can meet that demand overall? Again, not in just a single location. And a lot of times we say, well, we're not going to bring that online until we get certain things that are upgraded. If we've got new connections that need to be built, it takes time. When I was living in the UK, working with the energy regulators there, it was an 8-year queue basically to have your solar farm brought on board. So that kind of interconnection queue timeline is really difficult. And I think that there's a lot of work now going on even in the US to reduce those timelines for interconnects. Local resiliency, I think, is one of our hot topics now. I think with the weather-related events and the outages that we're seeing, my son lives in Missouri and he was without power after one of the extensive storms in March. He was without power for a week. And is there a way that we can utilize microgrids at a local level and behind-the-meter assets with storage to actually improve local resiliency? We've done a proof case with one of the investor-owned utilities in the East on this particular topic. What they wanted to do is be able to own the storage, which they're allowed to do in their regulatory area, and to offset the cost of the ratepayer to increase resiliency. They were actually going to use the flexibility into the local markets there. And using LMP pricing, we showed that yes, they could do that on top of increasing revenue by 50 grand a year by utilizing batteries. So it was really a cost payoff for them to justify a business case to the regulators, which is what they really wanted to be able to do. And then again, local asset integration. How is that going to behave? What assets are they? How do we steer those? Again, those are all questions. We do have, obviously, grid conforming inverters now, but rather than just turning it off, can we do something else with that? Can we send a signal to say, let's send that to the batteries? Instead, we've got storage on that feeder. Let's send it there, and then we'll utilize that a little later when the cost is higher. And then again, market-driven participation. This one is a really big one, I think, for demand response. Demand response tariffs in the US are not truly successful. I think that's kind of the general consensus of everyone I've spoken to. And again, coming from that space, it's very, very common. They don't incentivize enough for users to participate. So how can we, thinking ahead, how can we incentivize better in the possibility of doing markets, a flexibility market where they're paid for the auction and the activation could be something where they're given an absolute, they're given a time frame under their control of when they can participate and when they are paid to reserve that. And then also, again, as an operator, you have the ability to tap into that. And if not, then there's a penalty, obviously, for them to not allow that. But I think there's some things there that have been extremely successful in the UK. I'm happy to talk more about some of their models and point you in the direction if that's something you're interested in. And again, the flexibility aggregation, I think being able to take these small amounts of flexibility and utilize them to even bid into the capacity markets is something that's really good. And we can do that more now with this type of a simulator because we know what that flexibility is, what we have to offer. And so it's a little bit better to be able to make the decision of whether we can or cannot and at what price and how much. And then again, dynamic tariff optimization. What I mean by this is just essentially it's the business, the different business scenarios. So maybe right now we just offer a static tariff. Maybe we start looking at time of use tariffs and that seems to be okay. But when we start really thinking about dynamic tariff optimization, what does that mean for the users? And can we show them the value of that ahead of time? Sometimes that works, sometimes it doesn't, but we can at least look at historical information for maybe the last 3 years, understand and give them better information to educate them about what it would mean for them to actually look at this dynamic, participating in a dynamic tariff. So these types of sandboxes where you can prove out business cases, maybe if you're looking at new regulation in certain areas, being able to test that in this simulator situation with the flexibility makes a lot of sense. And again, this is something where I think being able to cut that time in simulation and the resources needed for that simulation creates a positive business case and a value to the operators, as well as their customers. And being able to look at this complexity of the value stacking. Again, I don't think we see it as much here in the U.S. as in the European region. But there are multiple ancillary services, multiple reserve markets, there's capacity markets, et cetera, that you can look at playing in with the resources that you have now, where you weren't able to do that before, perhaps. And then again, that testing the digital twins for changing markets and new value opportunities as new types of flexible load and flexible storage come onto the grid. How can we take advantage of that? So again, right now we have two products. The power of the simulator is our simulation engine, obviously. We do lots of variant testing there. This one is in release 2.0 right now, 2.1, excuse me. And it's actually becoming quite popular. That shows euros in the, we have European, but we also have USD versions as well. So we play in both markets. We've done proof of concepts and have customers looking at this in both markets. And then again, as we move into 2025, 26, we will be looking for partners, so to speak, and customers that are wanting to look at how do we do orchestration? Is this something that we can benefit from, and how that will work? Right now, we're looking at setting up a couple of labs in our Nokia Dallas office at the Energy Innovation Center. We are partnering with Dell for their edge compute platforms because they're hardened for substations, et cetera. And then start looking at how we really make that a reality and being able to send those control commands to RTUs, to inverters, to battery controllers and microgrid controllers. And so that's coming in this year. So it's really exciting to see, us make that leap into the real world there. This is more of a sales slide. Again, I think that it's really just about how we try to guide customers through this. It's a very different way of thinking about how we work in the power space. I feel that being able to show you how we utilize and create new templates for your data, how we can plug directly into your systems and get you to the place where you can run these scenarios is really, really key. We both both Enscryb team and our customers learn from this guided simulation, and you get really deeply into the technology and being able to hand that over then to you and have that be able to work and see how that works for you makes sense. And then again, that remote implementation is starting to integrate those assets into the orchestrator tool, and through the APIs and the gateways. That's that second phase where we actually help with integrating that into whatever your asset management tool is, whatever your SCADA systems are, et cetera, and start looking for that. So the challenges, there's no shortage, I think, of challenges in this space right now. Again, participation in DR programs, I think it's really difficult to garner participation from our members. I think that having the ability to show them how that would work, or again, incentivizing them differently through some sort of flexibility market would be a great way to go. We are talking with, I should say, some of the different platform providers that do provide markets in this capacity for smaller entities that maybe aren't part of PJM, or again, at that lower level where they don't exist. The division of responsibilities when it comes to who's responsible for system operation, who's responsible for the customer, the behind the meter, the customer relationship, that is still something that we need to work through. And we can do that within what we have in the system because of the way that we do hierarchical and aggregation groups. We can create multiple levels. And looking at this from a G&T perspective, we're trying to find ways to work at that G&T level and still empower the distribution cooperatives to understand what's happening behind the meter. And so really looking at as a service that G&Ts could offer in a hybrid way, so to speak. I don't want to use the term white label because it's really not a white label, but we're looking at that hierarchical view of where you can pull in information from the distribution co-ops that you need, and they still see the information they need from the G&Ts. And then the ownership of assets. This is something that we've talked a lot about. The example I'll give is in the UK. They had initially some really, really lucrative solar tariffs for feed-in tariffs. However, because they've taken off in so many places, we've seen it across the Netherlands and other places as well, they now have so much congestion because there's too much, absolutely too much power on the system. And so they're having to curtail. And what the UK did a few years ago was it was always the first in is the last out. And so they rewarded people that had been there for a long time with having a higher return on investment. However, that actually disincentivized anyone new wanting to put solar in because they weren't going to make the same amount of money, and it took them a longer term to realize the return on their investment. And so they had to find a new way. And when I talked to them, they said, well, this is how we do it now. I'm like, yes, but that's probably not going to satisfy the regulators for long. And so they had to find a new way to curtail, and doing this round robin of a more fairly and more equitable way of curtailment for across the entire, basically the entire grid, their area, right, of those solar owners who were doing feed-in tariffs. And so that's been a little bit harder now to do that. One way they do that, though, is again, they've got some sort of automated program within their flexibility markets or their market portfolio software that allows them to kind of manipulate that so it's more equitable and it's not just the first in, last out. And then again, these new business models, whether it's a new market, whether it's these virtual power plants, that's something, again, the aggregation of flexibility is working well. How can we integrate with that? It's something that we're going to have to do at some point in time, but how do we do that, and what makes sense in what areas? Because I came from an IOU, but I've worked with a lot of co-ops over the last 15 years, and I think that that's one of the things where what fits one side doesn't always fit the other. And so we need to find harmony somehow, or flexibility in how we can integrate what we need as a cooperative into what the IOUs are doing, et cetera. So I think that there is still some work to do there on business models, and what works for one may not work for the other. So flexibility in those business models is also something we're hoping that can be simulated, because we can take any kind of a economic stream as well, whether it's a market signal, whether it's a PPA, whether it's a contract or a time of use. All those things can be ingested into the simulator to play with, so to speak. So again, I think these challenges can be solved. I think we're on our way to looking at how we do this and how these can be solved. It's something that we try to consider of what the future looks like in 5 to 10 years. And that's sort of the Nokia Bell Labs heritage that we have. But again, we're hoping that, there's a lot of smart people out there, a lot of very clever people that can help with some of this. And as we move forward, we'll see continuing evolution of all of these different ways that we can make the most of both the renewables and the storage that we have in the system. So that's all I have for the slides. I will absolutely entertain questions. I don't know if we've got questions yet. I went through that fairly quickly. It's a lot to absorb, I understand, but yeah, it'd be great to have any comments or questions from the group.
I would have maybe a question. It's a good presentation, by the way. Thank you. So how do you keep track of the nodes? Okay, so basically, let's go for a practical question. So do you have a standardized way of placing those nodes, like, or it's a custom like decision for each of the utilities, depending? And I'm talking really on the distribution network, on the distribution side. Yeah. So I'll let you answer that if you can. So
yeah, we're working on a way to actually make a suggested optimization of those nodes. Now, those nodes are logical, David, so you don't have to have a piece of equipment out there. That's one of the reasons we went with a logical play. So even though you have maybe 5 nodes, they could still be in a centralized location. Like the compute could still live in a centralized location. So I think as we go to the deployment, we'll start looking at, how many feeders do you have? Is this an industrial complex? What's the size of the demand? What's the priority of the demand? Things like that. We'll start looking at more of those types of questions. But right now, we leave it very flexible for the operator to say, you know what, I have 3 feeders coming out of the substation. I want something there that if I lose communication and or power can still operate in a default way. So we kind of have left it up to the operator to decide. It also, I think the telecommunication circuit, putting on my Nokia hat for a second, the telecommunication circuit will have a lot to do with that as well, because when we go into that mode, we are looking at basically near real-time streaming of data. You don't always want to go across a private LTE link that may only be, a 3 megabit link. You may want to, in those locations, put a compute at the edge in order to bring efficiency to your network and not overload that SCADA circuit, so you can get back to your SCADA system what you absolutely need.
Okay, thank you.
Hussein?
Yeah. Hey, Liana, thank you for your presentation and sharing your perspective. I have 2 questions. Somewhere in your slides, you mentioned about orchestrator or orchestration nodes. I don't remember the term exactly. So when in the space of DERs and how they can collectively participate in providing grid services or in the market, etc., we hear terms like VPP, virtual power plant, DERMS, aggregator. How are these terms related to the orchestrator? Is it the same thing, or is it something that has overlap with those terms? I'm a little bit confused here. That's why I'm asking.
No, I completely understand what you're saying, and I get that question a lot because we struggled with that a little bit. We are kind of a meta layer on top of a DERMS platform, right? So we're not the controller at the microgrid level, and what we try to do is look at not just one location, but the entire portfolio. So we do sit at that VPP level, so to speak. I think the biggest difference between what we do and what a VPP does, we are only a technical aggregator. A lot of your VPP operators own the transaction as well and are trading on their behalf. We don't do that. What we want to do is we just want to be the technical layer to allow our customers to have control over that and not be dependent upon a VPP aggregator that may or may not be trading in your best interest. They have a reason that they exist, right? So we didn't want to take on that trade risk or that trade ownership as a company. We have 10 people full time. So I have basically maybe 15 or 16 with subcontractors. But So that's kind of what we want to do, is we want to be the technical aggregation program that would work like a VPP, but not own the transaction. And then that means that as you look at markets, you could actually build your own marketplace. We are looking again to partner with one of the new market platforms that's out of Norway. We try to enable you to utilize your DERMS program, but being able to, we can aggregate in such a way that you can either break up things that are electrically connected or group them together when they're electrically connected. So I think that's part of the difference with DERMS and with what we do. We kind of sit on top of that DERMS platform.
So who will be your targeted customer, or maybe I should put it this way, who will own this orchestrator, who will play the role of the orchestrator? I'm trying to understand it.
Yeah, so I think there's two parts to that, right? And this is where it depends on what you want to do. As a distribution operator, and this is the controversy that I get myself into. I believe that the distribution system operator or operators should be participating in system operation, because you have so much behind the meter that right now you don't know about and can't really control. You being able to balance at a home level, at a neighborhood level, and at your substation level before you go to the transmission operator makes a lot of sense when we have a high number of distributed assets. It also helps you offset your cost as a retailer, right? When you have to buy electricity, if I can utilize and balance and utilize this flexibility, I don't have to buy as much electricity, and that can help some of that as well. I still think, however, that there is a place where you have another layer of that system operation at the transmission level. So we're really, again, looking at bifurcated pieces there. We do play on both sides of the fence when it comes to consumers and the grid operators. In the co-op world, it's a little easier because you can work with your membership very easily, whereas with like an investor-owned distribution network operator, they can't tell their consumers, you can bid in this much flexibility. I've talked to a couple, the very large ones, in the eastern part of the US, and she's like, I can't go to my customer and say, here, I see this, this is how much you can bid in. But they can offer that service. One of the things we talked about in the UK is basically being one of maybe a handful of approved platforms where their consumers can utilize our technology to say, this is how much flexibility I can offer it, and then we connect with their bidding platform to operate that, to facilitate the transaction, but not actually own the transaction, so to speak. Does that help?
Yeah, it certainly does. And I have more questions, but maybe I can take it offline. The second question that I had on a different topic, you showed a deployment stage in one of your slides. If you can elaborate on that, what basically that entails?
Yeah, so we have orchestration agents. So essentially, our simulator is a larger version of what an orchestration agent is. So we take these orchestrator software and deploy that in a Kubernetes. Well, it's a Docker containerized environment right now. So it's really on a compute device at the edge. We're starting to talk to other vendors that have small devices because, again, a lot of times you don't need that much compute, depending on how complex the system is of what you're trying to configure and to steer. So in order to do that, we have, and I know Gitu, who is my head of software engineering, is on this call as well, so she may have to pop in. But we can deploy that either on-prem or in a cloud scenario. So it's a cloud, it's not a public cloud, it's a private cloud that is dedicated to you as a user. Or we can do an on-prem where it's sitting in some kind of a Dockerized container system that's then again has this agent at the end. We're working on that interoperability protocol between the units right now, between the agents right now. And so those two orchestration agents will talk back and forth to understand what's important right now in the system and what's not. So that's how we get the hierarchical capabilities.
So the end goal is that I, as the user, will see how it will play out if I take the offer that is now offered to me by the DSO. Okay.
Yes, and so you can actually see and deploy that. When you deploy that, you can what we call shadow mode. It's easy to simulate anything in a lab. We can make anything work, right? It's really when you deploy it where the rubber hits the road, so to speak. And so you're going to want to see, is this behaving the way I expected it to before you ever activate and actively steer and automate that steering?
Okay. Thank you.
Yes.
Yeah. Next, we will take the question from David.
Yes, thank you. So I was curious to know, does your simulation tools are all, do you have a suite of company-owned simulation tools, or you can also leverage third-party simulation tools in your platform?
So we do not, we can handle third-party simulations. It just depends on what we're talking about, right? So we don't do generation forecasting. We don't do weather forecasting. We don't do any of that forecasting. We take those as inputs into our system and
Okay.
add those to the mix. So yes, I think it depends, you know, again, digital twin has lots of different meanings depending
Yes.
on which one you talk to. So that's why
Okay,
it's
so
kind of
you
like,
can, okay, so you can take data and in some instances leverage simulation tools also.
yes,
Okay, okay,
yes.
okay, okay, thank you.
Farsad had a question.
Yes, sir. Thank you, Liana, for the great presentation. Farzad Ferdowsi from University of Louisiana. I have a question about the simulation engine. I was wondering what level of details is included in the simulation engine. Is it like an electromagnetic transient modeler, or does it capture grid information like the lines, inverters, and that sort of things, or just the DER and market data?
It's mostly DER market data. We put different, this is where I'm going to get in trouble for that, so I may have to refer you to Anton and Mark. I can tell you that we don't do reactive power at this point in time. We only do active power. Reactive power is something that's on our roadmap. Again, we'll just have to see how that, you know, when that hits and what the need is by our customers. What we're capturing really is just the DER and the market information. We assume a lot from the grid side perspectively. We are looking at some power flow modeling as well, but some of the other things, transients, et cetera, we don't do at this point.
I see. Thank you, Liana.
Next is Vidya. Please go ahead.
Yeah, thank you, Liana. Actually, Parag asked the question that I was going to ask. What we're seeing with VPPs that are just focused on market optimization is that there are scenarios where they would really lead to actual grid instability problems, especially when inertial groups are not modeled. I think my question is very similar to Prasad. Are you looking into the possibility of it being great for the market aspect, but not great in terms of the stability? And does the model extend into the actual system impact in addition to market play?
Yeah, it's a really good question. And again, probably not one I'm as I'm not an electrical engineer, so I don't know that I can answer it completely. When we start looking at how we do transients and reactive power, again, we are assuming certain constraints within the system for the operators that you cannot go beyond these things. But it is, like I said, we are looking at how would we model the transients, how would we model reactive power, because we know that the system operation is something that we need to take a look at from that perspective, right? I think it's going to depend on how deeply we go. Again, that's why we do things at the distribution level first, and we do a lot of behind the meter because that is a little easier to combine at the distribution level. But again, if it's something that we absolutely need to get into, we will. We're just kind of taking it. This is not, this is tangential to what Nokia does. And one of the PhDs is an electrical engineer that we work with. We've tried to abstract some of that as much as possible, just to show how flexibility can be utilized. But those are all constraints that we can put into the system. With it being near real time, again, as we do the optimization, it's very dynamic. The method that they use, and this is part of the patented methodology that we've built on from Bell Labs, is that it's not just a static, we look over a 15-minute time horizon and we don't change. In the simulator, that's what we go on because that's the data we have. When we go to Orchestrator, we're looking at every few, every half a second, every second, we're looking at what is going on right now, and we dynamically optimize to whatever's happening right now. So while I understand the concerns, I don't know enough about how it's going to work with transients to probably answer the question, Vidya, but it is definitely something we've talked about often. And so, yeah, we'll probably this summer start looking more at that when we get into the actual orchestration of connecting real-time assets and steering those to see how that's going to impact.
Thank you.
Okay, I think we have one more question from David.
Yeah. And I
No,
apologize,
no,
Vidya, probably that didn't answer your question the way you wanted it, but part of it is I don't know for sure where we're at with that, because I think that we still have a ways to go. Yes, David.
Yeah,
Yes,
no, thank you.
so I have a question about the edge computing. So I know utilities are installing new generation of meters with probably edge computing capabilities. They will run their own agent for their program. How do you come in? Are you going to be able to run in parallel with the utilities program and your agent side by side on have you looked into that?
I haven't looked at. I do know that a lot of the meter manufacturers are doing just that, right? They're putting on edge compute. Nokia has some relationships with LNG and with Itron, so it may be that we work with them. Nokia has some equipment from a broadband perspective, those co-ops or broadband providers, that actually the Docker container that can go in the house even and we can utilize that. So we can, depending on what they're doing, right? It's going to be something that could be seen as competition, but we can do more than just behind the meter, right? That's kind of the key, as we sit on top, because it's not just the house that we can do, but we can do the assets that are supply side as well. So we see them somewhat as competitors, David, in some ways. I think it's now getting to the point where it's not the best chip, it's now the best algorithm wins, and best model, right? That's kind of how we're going. But it will be interesting to see how the different types of technology, like I said, the way we do some of this over a time horizon, that time horizon can shrink. So we may fit into what they do. I've not talked to them directly on how they're doing their stuff, because again, from an IP perspective, it's hard to work with cooperators. But I think it is an ecosystem. We see it as an ecosystem. So it may be that they do the actual steering and we're doing the simulation, and we just tell the meter data management system, this is what you need to do, or tell the meter, the head end what it needs to do. So there are ways that I think we can work around that, depending on what works best for the customer. We definitely all need to work together and collaborate, which is why we're all API based, is because we know that that kind of ecosystem has to exist.
Okay, thank you.
There's a follow-up question from Farsad in the chat. Would you like to be able to give us an estimate for the cost of abstract twinning, like a dollar number per DER or a dollar number per node?
Yeah, so actually we try to make it really, and Stavros is on, if you might want to pop up, he's my chief commercial officer, basically. We really try to make it a low entry to the platform. So we do it a cost per simulation. So it could have multiple DERs in it. It's really the cost per simulation or project. We do things in the project base. So if you have a feeder that you're doing an entire project on, it may have multiple groups in it, and you run one simulation, but you run multiple variants, then there would be a small charge for the variants, right? But we try to make the platform, the entry fee to the platform, very low, and then allow you to run those simulations as you need them. So you can kind of grow with the platform.
I see. Thank you, Liana.
Any other questions from our audience here?
Yeah, yep, I'm looking at Hussein's question. P2's answering Hussein's question, so thank you, P2.
Okay, maybe I can ask a question here. So since you mentioned a simulation, this is following up to what Farzan and Vidya asked. What kind of a simulation tool are you running inside this platform, and what is that model of DER that you are using?
Yeah, so
to simulate all the impacts?
Yeah, so this is actually the Bell Labs technology that we're talking about, right? The simulation piece is our own technology. And the modeling language that we use, we actually developed, one of the guys that works for me developed the language that we use for modeling. So we create a generic model where you can go in and actually set the constraints and the different types, the envelopes, et cetera, to create whatever that is. So we've left it as flexible as possible. So we're not tied to any one type of model. Other than that, I probably need to have one of them answer that question, Rule, if I get too far beyond that. But like I said, that's some of the things that Anton, who's done a lot of our backend development with Mark, has developed part of the language that we use. So we try to black box that as much as possible because it's not something that we've seen other places.
Okay. Okay, that's I think we all had for you. Thanks, Liana. Thanks for answering our questions as well as giving a great presentation. So for our members, after a short while, we'll be uploading this presentation to our YouTube channel. That way you can access it from there, the video recording of this call we had today.
Absolutely.
Okay.
I just posted our website if anybody wants to check it out a little bit. Thank you so much for the time. Happy to reach out and have more conversation. Again, we've got our simulator platform is ready to go. If you want to see a demonstration of it, we're happy to set that up and get the technical people in the conversation, so they can answer more of the questions that I cannot.
All right. Thank you.
Thank you.
Thank you.
I know.